Hello, everyone. Let's wait a minute for everybody to join. Then we are going to start. Yeah, I think we can start right now. Hello, everyone. Welcome to the September edition of our Detection Highlights webinar. Great to have you all with us again. If this is your first time joining, so quick bit on what we're doing here. Every month, we run this session to share the latest updates coming out of our labs and platform development teams. That means any cool updates from the product side that help you sandbox threats more effectively. We keep it focused to highlight the ones, with useful context behind. So we are not going to share a whole batch of updates. So intros, I'm Ertuğrul. I do product marketing here, and I'm joined today after quite some time by Fatih Akar, my colleague, senior product manager. Hello, Fatih, who is focusing on threat intel these days. He will be walking us through a demo today. And yeah, good to see you, Fatih. And a couple quick housekeeping notes before we dive in. This session is being recorded, and we'll share the recording and slides with you afterward. Feel free to drop your questions in the chat at any point. We will leave time for Q&A at the end, and we will try to get to as many as we can. All right, with that, let's jump into what we've got lined up for today. The format is pretty familiar if you've been with us before. We will start with a few new VTIs, to be exact, 4 new VTIs. Like the previous one, focus mostly on fingerprinting behaviors and evasion techniques. That's how I would categorize that, if I may. And things malware does early on to learn about the system, or quietly exit if it's not worth the risk kind of behaviors. And we give a quick overview on YARA rules and 2 new config extractors we added recently. This time it's going to be around Vidar version 14.6 stealer, as well as CryptBot stealer, both really active malware families out there. And finally, Fatih will jump in for a quick demo. So the first VTI capability, really not so unique, commonly employed by threat actors. The score is 3 out of 5, and it's around hiding tracks type. We already had VTIs for a basic file deletion, but this behavior was a bit different. The sample create a batch file, then execute it to clean up after itself. So a bit more context. While monitoring video spy, also known as wet fossil, we noticed this and wanted to flag better. And as you may remember, by the way, we recently added config extraction for this family, and we had chance to show you how the config extraction for this malware looked like in previous webinar. And specifically, it would run a hidden command that runs the batch file from a temp directory, and finally .bat file deletes itself and the original process to wipe traces. So the coverage is extended to pick up this pattern, to catch this kind of cleanup routine. Next up is a network-focused VTI. This one came from one of our analysis of Prometheus botnet malware, which if you followed again previous sessions, you will know we have been keeping an eye on for a while. So Prometheus is fairly evasive and like really a lot of botnet malware. It tries to assess really whether the host is even worth engaging with. So in this case, it uses ping. Who doesn't use ping, right? To check the connectivity, a simple test to see if it is online and can reach external infrastructure. Typically, it's pinging Google and other well-known DNS providers. So we already had a related VTI that flags use of system-info.exe to gather operating system data. That this one is similar in intent, but focused on more the network layer. So it's currently scored 1 out of 5, just as informational signal. But as usual, as we observe more patterns, or if it often leads to malicious activity, we may increase the score over time. And for now, it gives helpful context when you're looking at a kind of broader sequence of behaviors, especially when paired with other discovery or evasion tactics. The third one, so this one is a bit different, and I wanted to spend more time really on it, not because of how it works technically, but because of why we built it and how we approach when it comes to VTIs and new detections. So recently we added a low scoring VTI. Here what we flag is when a phishing sample interacts with domains using TLDs that are frequently abused in phishing campaigns. You know the ones, for example, .shop, .zip, .click or .tk, especially these type of things. And a bit more context I'm going to share right now. We often develop, in the security world, a bias against certain TLDs, right? And when speaking about bias, also check out the image here. Most of you should have seen before. I can't resist adding it, but I don't have time really to speak over it. But I can tell you, I think it was from Second World War. It was around an airplane got hit many times. So getting back to our topic. So when you see .tk or .shop and your really gut feeling says that's shady, right? But as a sandbox and also from an accurate threat intel perspective, we try to avoid that bias. So our stance here is behavior is greater than reputation. So that said, domain reputation is still valuable, especially for phishing. But I'm gonna describe here what our labs team did, and I think that's very smart. The process here, you can see a quick flow of how it works. So every month or two, they run a query in our internal data lake to look at submission data. So we submit thousands of samples to our internal instances. And we look for TLDs that appear in the analysis reports of these submissions, and then calculate the malicious to clean ratio per TLD. And based on that, we update a list of high-risk TLDs and manually review it to exclude some, some of them like .com or the country TLDs. Then use that to trigger this VTI. So we are starting here with a score of 2 out of 5 to keep it relatively low noise, but we increase it if we see it consistently correlating with phishing. So one extra note, we are also sharing this data with our AI team so they can use these ratios as features really in phishing detection models. So it feeds into multiple parts of the system. And Fatih is also going to speak more about a very recent improvement with our third release of the year around the computer vision AI later. in the demo part. So bottom line, reputation is useful. That's why this type of bias here we see, is called survivorship bias. So it helps us survive. It's a good thing. But in our context, it's much better really to be data-driven and especially possible combine it to behavior data. So hope that all makes sense. And the last VTI of the day, this one is a really interesting behavior that came up thanks to feedback from one of our customers. We added a new one that detects when a sample checks for the keyboard layout settings and then terminates early. So often within the first few seconds of execution. So more context, this is a tactic we've seen in families like Stealer, which has previously targeted Germany, Spain, and Ukraine. The customer suggestion was actually to mark any sample that checks the keyboard layout as malicious, but we know that would lead to too many false positives, right? Since that API is used by a lot of probably legitimate software. So instead, we refined it with a combined trigger condition. So if the sample terminates early and keyboard APIs, like, as you can see here, I get keyboard, get text, get user GUID. If these are seen, then we trigger the VTI. So this is a strong indicator of region-aware evasion. We set the score as 3 out of 5. It's really a stronger signal compared to other behavioral VTI. So unfortunately, no data around which countries they don't want to target as of now, or they want to target. And I don't like to speculate, so we will leave it like that. As more data will be available, maybe in the future, we will be able to share more on that. But we know that some ransomware families, almost many ransomware families, for example, they don't target post-Soviet countries, so they just terminate it. So it's kind of familiar kind of perspective thinking. And yeah, lastly, it's really a good example of how we balance detection coverage with the need really to avoid noise. And I think that's a common challenge for all the security operations centers, all the analysts, all the practitioners out there, and how customer feedback can really sharpen that logic. So we are really happy to have feedback from our customers on the threat state phase. And so moving on, let's talk a bit around the YARA rules. So it's really a quick look here, what you see on this slide. You can see the loaders, downloader malware, infostealers, and phishing kits. So we have added coverage for these threats that you see on the screen. But I wanted to pause for a second on something a little different that we have been adding more of recently, which is YARA rules for EDR evasion tools, for EDR evasion. And EDRs, obviously great for visibility and, also for detection across endpoints, but they are not bulletproof. And attackers know that. There are plenty of tools out there specifically built to bypass, disable EDRs. So then actual payloads will get dropped easily, right, under the radar. So for teams doing especially instant response, or if you are bulk submitting, for example, suspicious files into the sandbox, these rules really can help you quickly identify, hey, this is not just a loader or malware. This is a tool built to silence the EDR. So this can be a starting point when you look at the tactics and overall the chain, right? And sometimes not really your usual suspect like Cobalt Strike or whatever Agent Tesla. It might be something like EDRKillShifter, which also is observed to be linked to the ransomware families like RansomHub and others. So really good stuff. More visibility, faster triage. This is kind of what we want. Fatih, at this point, would you add any insight around the how Sandbox can be integrated into EDRs and for faster triage.
Yeah, definitely. Basically, VMware platform, supports all of these capabilities that you can do in the user interface through its API. And through this REST API and some custom integrations with various EDRs like SentinelOne and some other vendors out there, we can integrate and collect the file, analyze it within a couple of minutes, and then just return the entire analysis report. And this is particularly important because on the endpoint, the EDRs or any kind of other sensors over there do not have the hardware resources that a Sandbox can have on somewhere else in cloud or somewhere in the perimeter, right? So we're able to just spin up a full-fledged virtual machine on the spot when the REST API is called, detonate that file, and just try to observe its behavior in like 2 minutes or maybe even 3 minutes, and dump all this information, extract IOCs, and just see the behavior, and we can report back to that EDR with the corresponding indicators of compromise. And the EDR can then just do all kinds of other operations, like blacklisting all of these additional indicators that wasn't even originally seen in that the first stages of the attack. So it's particularly important to have this enrichment capability by integrating an EDR or maybe even a SOAR to a Sandbox-like or a threat analysis platform like VMware platform.
Amazing. Thank you, Fatih, for jumping in. And by the way, if you're more interested on this integration, we have an upcoming webinar October 14th around how VMware can be integrated into Microsoft ecosystem, Microsoft Defender for Endpoint, if I'm saying it right, the product name, because always is kind of changing, some confusion. So yeah, you can get more about that integration as well. All right, so before we wrap up, quick look at the config extractor updates. Last month, we added support for 2 Stealer families that really continue to show up in Sandbox submissions. First up is Vidar, which is constantly getting small updates. We now added support for version 14.6, so we can reliably extract its configuration even as it evolves. And there is CryptBot. This is something that we mentioned in previous webinars throughout the year as well. So another active stealer, a particularly interesting one when you extract the config data. So this is also something that we have added configuration extraction support. And with that, I will now hand it over to my colleague Fatih to walk through what this looks like, how the analysis looks like, how the config extraction looks like in a real sample. Stage is yours, Fatih.
Thank you very much, Arturo. Thank you very much for the great presentation. And yeah, basically, we've shipped many things with these threat detection updates. And particularly interesting 2 malware families that we had an additional config extractor for was, again, as Arturo said, is YARA and CryptBot. And the reason why we choose these malware families is because they are still seen, as Arturo showed the numbers and the histogram of their occurrence. They basically represent also the business model shift, as some of you in this webinar already know. It's cheap, widely available malware as a service stealer business going on that even the low skill actors harvest lots of credential and cryptographic wallet related information, and it is just explains why credential compromise is so common today. And they not only target the consumer artifacts, but they also target the enterprise. They try to collect a lot of browser files, safe passwords, cookies, and crypto extensions. And so anybody across the IT spectrum, including the security guys, need to care. And they have such a common, distribution matters like cracked installers, very, very funny one. Malvertising, as you know, it's pretty interesting. And also the most notorious one out of them all is the phishing. You know, it just illustrates how user behavior and web advertising ecosystems and all kinds of other risk vectors your basically members in your organization often underestimate, right? And I will just now just talk about how we do the analysis for the CryptBot and what's new over there. And I will just share my screen here, and hopefully you now are able to see the notorious user interface of VMware platform. And this is the analysis report, basically a detonation of a CryptBot malware sample that we were able to just find. And just let me give you a background story around CryptBot. It's basically an info stealer that targets users' sensitive data, just steals everything, often focusing on cryptocurrency, as it's very understandable from its name. It's known for stealing login credentials, private keys, and all kinds of other sensitive data from cryptocurrency wallets, from browsers, all kinds of financial applications and other services. And again, the common delivery format for it is cracked software installers. It's still out there. So malicious downloads and again malwareizing. Attackers just piggyback on software cracks to push the stealer, basically. And one of the notable behaviors out there is the fast collection and exfiltration. And you will see in a second that this is an analysis that is done under 2 minutes. And of course, VMware platform shines with its 50 matches with its 37 rules on the behavior, but also it is notably interesting for what this malware sample can do under two minutes to just trigger all of these rules, right? So you can see that the sample is not only having a verdict of malicious, so you can understand that it's something that you need to be afraid of, but it's also saying it's an injector, it's a spyware, it steals data. And there's also the malware family classification correctly assigned to it as CryptBot. And we not only have this classification correct, but we also have, again, as I said, 50 matches across the board with 37 rules. Not only the static rules like YARA, like antivirus and reputation. As Arturo mentioned, we are mostly about behavior, and behavior always beats the reputation, because reputation does not tell you that much for an investigator, for an incident responder, or a security operations center. Hey, something is malicious, but how do I start my investigation? What do I need to know about it? So you need to be having a lot more context into the alert that you might have, or the analysis or the investigation that you keep started. So even if you didn't have these static matches, we have all kinds of behavioral matches on here. We've observed that it's just trying to command other input captures, right? It takes a lot of screenshots. It tries to inject to other memories, other processes' memory, which is particularly dangerous in itself, because now at this point, the sky is the limit for this executable in your environment. And it not only does that, but it tries to evade a lot of things like debuggers and some of the other virtual machines, like forensics tools, like sysinternals. Maybe you have sysmon, and if you have sysmon, you would probably basically this malware wouldn't be running in your own lab, because it just tries to detect all of them and just do not show the behavior. But in the VMware platform, we see, because of our evasion resistance, we are able to let it run and just show all the nasty behavior that it has, and just take a note and create this repeatable report to you, so that you have all the context that you need analyzing a particular threat like CryptBot. And again, we mentioned in this release, we've had such a success on detecting the VTI, detecting the behaviors through our threat identifiers, but we also have extracted the configuration out of it, which is just recently shipped. And when I want to go there, I can see the malware configuration is here. So when I toggle that on, I can see all kinds of other stuff that the malware author embedded and hidden into the sample itself, right? Like the encryption key here. It's Zora encryption, and we are able to have this key extracted. And we also have the URLs over here, which is basically extracts, the location from which the malware downloads additional malicious payloads, right? And in addition to these main fields, we can now extract a variety of other critical configuration details in that CryptBot uses to target and steal the data. And these include browser data and wallet data, some system and user data like file locations, and also a lot of anti-detection and persistent mechanisms that it embedded itself. As you can see, all of these settings are basically configurable by the malware author itself, and we are able to extract all of these information immediately after it. So we continuously take screenshots throughout the analysis, as all of you already probably know. And it's just a binary, it's a calculator. It doesn't say that much, but under the hood, a lot of execution is happening. Basically, you see it's nothing much on the process tree, but even with the red arrow, you can see that the main sample process is trying to inject into the other child processes that it created, and that just is just starting everything, right? And all of the behavior is not only detected by our VTI rules, but also mapped to the corresponding MITRE ATT&CK technique IDs. So you can just take a look individually and get further information from within the MITRE ATT&CK corpus, so that you have the same language with what the industry is speaking, and you can continue all kinds of other operations like detection engineering. Maybe want to do further threat hunting on that particular threat or the behavior. And this is basically speaks for itself. And when we look at the the behavior, let's go to that injection behavior where we mentioned that it tries to write into the memory of another process. And when I go to there and say to go to behavior, VMware platform will redirect me into the behavior tab, where we will actually focusing on the right operation in the memory. And it is done by a particular executable process, and we know what the address is, right? What the size is. We also can look at the function call logging, which is a unique feature from VMware platform. We not only are able to detect the behavior, but we also can go down to the very microscopic details of what function call did this sample or this executable called for, and not only the function call's name or the API call's name, but also its parameters. And in most of the scenarios, you would have it human readable, and we can see that the NT write virtual memory is being called here. But not only we can see how it is being injected, but we can go to the data section and see what is being injected. And this is particularly important. As you can see here in the hex dump that we can provide, you can download this and do all kinds of other operations on it, or other research on it. But it's an MZ header, it's Mark Zivikoski, the notorious one, and it's an executable file, right? And this is, again, that's where it's up to the creativity of the attacker on what it will inject, because it's an arbitrary code piece being executed on a memory, and this could reveal all kinds of other information. And just going to the other tabs, as you can see, we noted down a lot of behaviors for that particular process. We are able to extract and see all kinds of files downloaded, dropped, embedded, extracted in the files tab. And if this was what CryptBot was doing, you would be able to certainly see other malicious file here. But what is particularly interesting in here is when I go to the AV and YARA tab, which we pressed on the reputation so much, right? It's really important that you have this information, but you shouldn't limit yourself, your detections based on only this repetition. So when we go to the AV matches and YARA matches, we have a bunch of stuff, right? We scan all the memory dumps, including the sample file with AV and also with our YARA rules. In the AV, we were lucky that we got a match on the sample file along with the other memory dumps. But in the YARA rules, if you have a YARA rule, you might want to scan it on a sample itself. But as you can see, the file type here, there is not even a single instance of a sample file match on the YARA rules. So all of these YARA rules that we were able to match on this was matched on memory dumps. And this is particularly interesting because, you know, most of the malware out there is either packed, encrypted, or encoded in some shape or form so that they actually do not allow the YARA rules to be scanned on themselves and get a match and just notify the security admins, right? So what they do is they do these packing and encryption operations, but the operating system does not able to execute at that level. So you need to the binary needs to change itself in the memory, trying to execute itself, and they need to unpack, decrypt, and decode itself so that the operating system can have the code piece that it can execute on. And on all of these stages, VMware platform has certain triggers for a memory dump to be taken. And when there is a memory dump to be taken, we take the dump and we scan our YARA rules on them as well. So even if it's a packed malware, we do not care, because in the memory we see the version where our YARA rules will be matched on, and that's again the CryptBot and all kinds of credential stealer generic YARA rule files that we have with you know pretty lower score. But again, we were able to classify all of these and just get you such a understanding on a deeper level if you wanted to have such a certain visibility on it. Going to the indicators of compromise, where it's more relevant to folks like CTI analysts in CTI teams, where they want to actually dump these IOCs and maybe use them further in different products. Maybe they want to reach out to these IOCs endpoint and get them through the integrations that we have through the EDR or SOAR that they have. Here again, we were able to mark all of these IOCs, the processes, the files, and domain names. Here we can do the relation. There's like a lot of network connection to that domain address. And going to the URL, this is interesting. We were able to extract this URL, which was a configuration that malware author put into the sample. We extract this after decrypting it, decoding it statically. But we not only extracted it, but we also observed the same URL being called and be contacted inside the analysis time period, right? So it just tells you that this configuration that malware author put was also visible in the dynamic analysis. So you can continue on and see the other IOCs over here with all the related VTIs. So that means we not only extract the artifacts, but we also score them or classify them as indicators, as IOCs, and we also score them depending on which malicious behavior, the level of malicious behavior that they were attached to, they were entangled with. And we do this relationship mapping. So not only you have the indicators of compromise, but you also know which behavior it's attached to. If you want to do a further, more advanced use case, like detection engineering and threat hunting, you might want to unfilter all the artifacts that we didn't include originally with the toggle on the left side. Now you can see all the other clean IOCs that we saw. You can see registry keys, the file names that were contacted or just opened, accessed, read, or deleted. So even if it doesn't tell you that much with itself being there, but maybe the order of these being contacted or executed or just read can reveal so much information to you. So if you want to go further, VMware platform allows the analyst to do so. And that was the first malware family that we mentioned. The second malware family, which was YARA, and I have another interesting report in front of me right now. And also, let me give you some more detail on the YARA. YARA is also an information stealer, the info stealer. It's based on archive stealer, and it's well known for abusing platforms like Telegram or Twitter as part of their command and control infrastructure. And it distributes itself via phishing attachments and links. Sometimes it's drive-by downloads. It does also malware advertising like CryptBot does on Google, right? And the latest release of YARA, which is 14.6, introduced changes to its internal configuration structure, which through this configuration extraction update, we meant to we realized that the existing extractor that we had for YARA no longer worked out of the box. So after analyzing the new structure, we adapted the tooling, and so that configuration can now be successfully parsed from this version as well. And here you can see again malicious verdict, spyware, stealer, but this time it's YARA, right? And you have not that many different VTI rules, but you can have this particularly interesting VTI, which is talking about the exact same thing, the extracted configuration for 14.6. When I go to the malware configuration, you will see some really important stuff over there. You will see the URLs. Again, the Steam is another distribution method for it, just like Telegram. And you can see not only the first stage CTU through Telegram, but also the second stage CTU. So you will be able to understand where it's reporting to and immediately jump onto that Telegram channel through an isolated view, of course, and see what it's doing. And yeah, basically that's it for the YARA. Of course, we have also some other behaviors for it, like anti-analysis, behavior evasion, behavior being detected, delays execution, and yeah, it's just resolves API functions dynamically by name to evade some other stuff through its obfuscation. But again, it just shows you also through its remark that we triggered the anti-sleep mechanism that we have, right? The overall sleep time of all the monitored process was supposed to take 20 minutes and 43 seconds. And the malware authors do this to evade detection again in environments where you have the EDR installed, or maybe it is trying to be analyzed by sandbox. So they sleep until this timeout limit being hit, so they evade the detection. And we were able to, through our hypervisor-based analysis, we were able to lower this to 21 seconds. So it's just, and it's automatically being done by the VMware platform to just show all the behavior. And the malware thinks it's running on a endpoint where they're infecting something. And that just shows you how much a platform like this can help you analyze such behavior in detail. And last but not least, in my demo, I will talk about the visual AI approach to phishing detection. It's the computer vision VTI rule, which is a behavioral detection rule that we just really recently shipped this mechanism. It's not just a behavioral rule, but a new method in the product to be trying to detecting the phishing pages. So with this release that happened a month or two ago, we are raising the bar basically in phishing detection by introducing this computer vision AI for phishing, which is a powerful enhancement to our existing whole entire threat detection stack for VMware Cloud users. And basically, the phishing, as you know, is a visual deception. Most of the phishing sites are designed to fool users and not the machines, and they mimic familiar brand logins like Microsoft, like Adobe, and some other stuff. And they try to visually replicate the legitimate pages, right? And that's why detecting phishing effectively means analyzing it the way a human would visually. So with this 2025.3 release, our platform performs a computer vision-based analysis on all the screenshots that are captured during the web analysis. And this screenshots of web content are passed through an object detection AI model, which mimics the user and how a user might perceive the page by trying to detect whether a web page is a login page based on visual structure and layout, recognizing the brand logos. And again, this model analyzes the screenshots independently from the DOM structure, because we wanted to make it more resilient to the DOM of obfuscation, which we see it very often from the phishing threat actors. And basically, these VTIs are going to be powered by these models, and it just gives us more resilience against DOM evasion, better brand spoofing detection, and it will increase the efficacy and as well as the efficiency. So here, on a sample that we have, which is classified as phishing, malicious, right? We scanned the YARA rule. We were able to match a heuristic rule, but and some discovery related behavior which checks external IP addresses and so on and so forth. But this VTI, although the score is not really high, just gives you a lot more context through its AI capabilities, right? Basically, when you look at it, you look at the screenshots, it is obvious to you that this is probably a phishing attempt that is mimicking meta pages, and you can understand it. But through the DOM, when you're inspecting the HTML or CSS code, it's really hard stuff to try to understand what's happening here. But through this screenshot, for a user, it's immediately visible for an experienced eye. And that's what we're doing. We're actually, when I want to go to that here, we're actually taking all these screenshots and all the requests and just putting everything into the AI model and getting the response. And it just gives us much more insight on it. And when I go to the network tab, which we didn't touch on it, but you can see suspicious looking words of that app, top level domain, and over there we have multiple requests having been done to this domain. We can not only see the request, but we can see the response and how this response has been conducted by the server. You can see the DNS request, what was the IP address behind it, the TCP sessions, and if there's any need for a further analysis, we can even give you the raw PCAP stream on the session. And we can also give you the SSL certificates so that you can do all kinds of fingerprinting on Java 3 fingerprinting and so on and so forth to facilitate further detection purposes. And with that, I think we're through with the demonstration of these new extractors and the new AI capability that was added to VMware to improve detection with a real world threat over here. And yeah, thank you very much. I'd like to pass it back to Arturo now.
Well, thank you, Fatih. That was an amazing demo. So as you just saw from Fatih's demo, so we're not only sharing the updates, which is really frequent, like weekly updates from our labs team. We are also sharing here some updates that we categorize as release updates or platform updates, like computer vision AI. So that requires more effort in the background. And so, yeah, that was all good. Thank you, Fatih, for all the insights. And we will move on to the Q&A in a moment. So before that, as you know, this is usual that we are sharing the resources that you would like to check out. And make sure also you take a look at our blog posts, our blog, where we also publish the list of all the updates from our monthly detection highlights and also the platform updates we just mentioned. All right, so that brings us to the Q&A part of today's session. I can see a question around the encryption key, Fatih. I don't know if we are able to know the answer to this question, but the question is around the encryption key that you shown in the CryptBot report. Is it public or private? I mean, I tend to say it is private, but
We currently have no information on it because if the key is being, having the same pattern with what we're trying to extract, then it will be extracted. So I don't know if it's a private key or public key. I can get that information for you by just talking to our threat researchers in our labs team. But regardless, it's a very important key because even if it's a public key, that means you're not going to be able to, if you don't have this information, you're not going to be able to see what's going on with the C2 communication. Maybe the private key
All right.
is in the server side, in the C2 side, so yeah.
Okay, all right. So, I mean, if you get in touch with us, we can definitely get back to you with the information. And a quick one on AI update, Fatih. So, I think this is for you as well. There is lots of noise around it, obviously, but I think the value for this one is very relevant. So, have you seen any edge cases where this computer vision model struggles? For example, if attackers slightly modify logos or or hide them behind overlays, how resilient is the model in those cases?
Yeah, basically it's been trained by many different examples, like the high volume of data we have on phishing URLs, and the content was basically simple. If it's a login page or if it's trying to mimic a brand, you are going to consider this as or classify this as a phishing if we don't have the other mechanisms. And from that front, it's particularly resilient because sometimes the DOM does not render itself on the fly because it is not meant for that resolution, or it's not meant for some other stuff for that browser. It doesn't render correctly. In the analysis in the machine, you cannot read it because there might be some DOM injections in the later stages. But if you take a screenshot, it's really clear for a experienced user that to say that it's phishing, and that's what we are trying to mimic. We are trying to mimic our expertise in the threat research team in our labs team to get the same level of detection handle on those pages, and it just is such a nice way to support the real detection that we do on the code base, on the HTML, on the DOM itself, right? So and we haven't observed so much false positive around it, so the efficacy is looking great on that side.
And I think
Hope that answers your question. Yeah.
As time passes by, with the learning continues, with more analysis reports and accurate data, I think it's
Absolutely.
improve and adapt, right? Another quick one, on the threat intel side, we talked a bit around the VTIs improvement and about how we use our sandbox insights from our own submissions. Can you share a bit more, how to benefit from these, sandbox outputs integrated to threat intel platforms, threat intel workflows?
Basically, this is a common use case from some subset of our existing customer base. They utilize the output of the VMware platform and extract these IOCs, because everything that you see on the screen through my demo is accessible through the REST API that we have. We have a significant coverage over there. So you can just pull all the data, even with the 62.1 format, which is a native structured threat intelligence exchange format for various security platforms. And you can, through that means, you can get those indicators automatically through other products and create detection alerts out of it, be it SIEM, be it EDRs, be it threat intelligence platforms, where you might want to do curation yourselves, or maybe even enrichment yourself through another platform. All kinds of integration scenarios are possible. But yeah, I think.
Yeah, amazing. I think it's also relevant to note down here that VMware has a new product called Unique Signal. So what we do is we are providing machine readable feed around emerging malware and all the IOCs and context as a feed, which is Stix and Taxi compatible. So if you have a platform that can ingest this, so you can easily integrate this feed to your threat intel workflows. So you can check out our website to get more information on Unique Signal, our new threat intel feed. Amazing. So thanks for the great questions and thanks for the insights, Fatih, again. Before we close, a quick reminder, the webinar recording and slides will be shared shortly. And if you got feedback or questions we didn't get to, feel free to reach out. Fatih and I are both active on LinkedIn. Not too active, but just enough. We would love to hear from you. And mark your calendars. Our next detection highlight session will be on October 22nd. Already we pinned that down. So thanks again for joining. Really take care and see you next month.